If I asked you right now to picture a map of the world, the first thing that would pop into your head is definitely that classic image we all know. The Americas on the top left, Europe right in the top center, Africa just below it, Asia on the right, and Australia tucked away in the bottom corner. But here's the kicker. This map is actually wrong. For example, South America isn't directly beneath North America like you see it, and Europe, which we all see sitting right across from America, is actually located much further north than it appears on the map. So, let me show you the world in a completely different way than what you're used to, and let's find out how a 500-year-old drawing still dominates our minds today. Welcome back! Before we dive in, if you're new to the channel, don't forget to subscribe and hit the bell icon so you never miss any of our latest videos. Every single one of us has an image of the world map burned into our subconscious. We automatically refer back to this exact map the moment we hear a country's name or think of a faraway place. The problem, though, is that our mental map isn't always right, to the point where our perception actively resists correction, even after we learn the truth. John Nelson, an American cartographer, says there are many reasons behind our geographical misconceptions. First off, names themselves play a huge role in how we misunderstand maps. For instance, we all think South America is located directly underneath North America. It makes sense, right? One is north, one is south. But if you look at an accurate map, you'll find that the continent of South America is actually located almost entirely east of Florida. That means if you're in Miami and you look straight south, you're looking at the Pacific Ocean, not Colombia or Brazil. This whole thing really obsessed John Nelson and his entire family. His dad, a geography professor, published a research paper on these geographical misconceptions. His mom, a high school geography teacher, co-authored the paper too. Because of this, Nelson decided to create an interactive map highlighting the 3 most common geographical mistakes people make, stating that most continents are not where they actually belong. Take Africa, for example. It's the very first victim of our skewed perception. Most people in North America and Europe think the continent of Africa sits entirely in the southern hemisphere, just like South America. But the truth is, about 2/3 of Africa's landmass is actually north of the equator. The same mistake happens with Europe. On the map, Europe is placed much further south than it actually is, making it look like it's directly across from the United States. In reality, Europe aligns much better with Canada. For instance, Paris is actually further north than Montreal, Barcelona in Spain shares the same latitude as Chicago, and Venice sits on the exact same latitude as Portland, Oregon. Part of the reason for this confusion might be the climate. Western Europe is relatively warm compared to the latitude it sits on, and that's all thanks to the Gulf Stream, which carries warm water from the Gulf of Mexico across the ocean. This gives Europe a climate that feels more like the US than the freezing Canadian cold. Because people naturally associate warmth with the South, the entire continent drifted southwards in our mental maps. To understand why our brains map the world so incorrectly, we have to go back to the fundamental problem that has plagued every single cartographer throughout history. Imagine you have an orange and you want to peel it and flatten that peel onto a table so it forms a perfect rectangle without tearing. Impossible task, right? That is exactly the challenge mapmakers face. The Earth's surface is a 3-dimensional sphere, and it is mathematically impossible to represent it on a flat, 2-dimensional surface without some form of distortion. The German mathematician Carl Friedrich Gauss proved this mathematically in 1828. He confirmed that any attempt to flatten a sphere will inevitably distort one of 4 things: the shapes of countries and continents, their relative areas, the distances between places, or their directions. Inevitably, no flat map can preserve all 4 of these elements at the same time. You always have to sacrifice one to keep another.
Based on this dilemma, cartographers started resorting to different methods to draw maps. To transform a spherical world into a flat map, they used what's called a projection. What they do is place a light bulb inside a transparent globe and wrap a cylinder of paper around it. The light coming from the bulb projects the shadows of the continents onto the paper cylinder. When you unroll and flatten the paper, you get a rectangular map. This is known as the cylindrical projection, and it's one of the most famous types of projections out there. But it's not the only one. Other shapes are used too, like cones or flat planes that touch the globe at a single point. The issue is that every projection method gives us a completely different map, and each one comes with its own set of compromises and trade-offs. Some maps might be incredibly useful for a specific purpose, like navigation, but at the same time completely misleading if you're trying to understand the actual sizes of countries. Hands down, one of the most famous projections ever used is the Mercator projection, a cylindrical map drawing method. In 1569, a Belgian cartographer named Gerardus Mercator drew a brand new map of the world trying to solve the biggest problem facing sailors. Since the Earth is round and sailing routes are curved, it was incredibly difficult for sailors to plot or maintain a constant bearing. Mercator came up with a brilliant map that was basically the GPS of its era. His map made planning long-distance sea voyages significantly easier. To achieve this, he made the lines of longitude parallel and stretched the lines of latitude the closer they got to the poles. The result was a map that was perfectly accurate for directions, but it severely distorted the actual sizes of the continents. Even though Mercator originally created it strictly for sailors, it remains the standard to this day, and it's the exact projection used by Google Maps right now. The biggest issue with the Mercator projection, despite solving the navigation puzzle, is the terrifying distortion of sizes and areas. The way Mercator designed it caused any landmass near the equator to shrink, while any landmass far from the equator and closer to the poles got massively exaggerated. The most famous example of this is comparing Greenland to Africa. If you look at a Mercator map, Greenland, the massive icy island in the north, looks roughly the same size as the entire continent of Africa. To the naked eye, you'd swear they take up the same amount of space. But what most people don't know is that Africa is actually about 14 times larger than Greenland. There's a website called The True Size of that shows real landmasses without any distortion. If you go to the site, search for Greenland, and then drag it over to Africa with your mouse, you'll see it shrink down until it looks tiny. And this illusion doesn't stop at Greenland. Alaska, the frozen American giant in the north, is actually slightly smaller than Libya in reality. Brazil, which doesn't look all that impressive on the map, is actually larger than the entire contiguous United States, without Alaska and Hawaii. But because Brazil is so close to the equator, the Mercator projection shrinks its size. Africa itself, which looks relatively small on the map, is actually larger than the United States, Canada, and China combined. Unfortunately, these distortions alter our fundamental perception of the world. Entire generations grow up seeing certain countries as much larger than they really are, and others as much smaller. This creates an unconscious bias in the human mind, a bias with implications that run far deeper than just a simple mapping error. Many critics argue that this bias was no accident. The Mercator projection served specific agendas, painting a world portrait that favored the interests of major superpowers at the expense of everyone else, reinforcing European dominance over the rest of the world. This is because the Western nations are the ones whose sizes are most noticeably inflated on this map. Meanwhile, African and South American nations, many of which are classified as third world countries, had their sizes aggressively shrunk. Psychologically speaking, when your country looks like 1/10 the size of the European nation trying to colonize you, your mindset is going to be completely different than if you saw your country as larger than the colonizer. And the bias wasn't just about size. Europe always appears right in the dead center of the map. This gives off the impression that it's the center of the universe and that everything else revolves around it. Of course, that's not true. A sphere has no center. Any place on Earth could be the center. Putting Europe in the middle was a deliberate design choice reflecting a Eurocentric worldview. Even though the Mercator projection remains the dominant force in cartography, a new projection called the Gall-Peters projection emerged in 1855. This projection was born as a rebellion against the Mercator map, which had cemented European superiority over other continents. The new map was an attempt to bring justice back to the cartographic world, prioritizing accurate sizes over aesthetic appeal. Suddenly, Africa reclaimed its massive, true size, South America expanded, and Europe and Greenland shrank back to reality. But the price was that all the shapes became stretched and bizarre, looking like the continents were hung out on a clothesline. Despite the unfamiliar look, supporters argued that sacrificing visual beauty is a small price to pay compared to distorting the truth. The debate between Mercator and Gall Peters turned into a philosophical battle: what matters more? Shape and navigational accuracy, or size and geographical justice? Out of this debate, the quest for the perfect map truly began, leading to compromise solutions like the Winkel triple projection. Created by German cartographer Oswald Winkel in 1921, its goal was to minimize size distortions while preserving directions and distances. He actually succeeded, and in 1998, the National Geographic Society adopted it as their standard projection for world maps. Other unique maps appeared too, like the Good Homolocene projection, which splits the world like a real orange peel to keep the continents accurate. Yet, the strange thing is, despite all our advancements in navigation and the rise of GPS, the Mercator projection still rules the world's biggest navigation apps, like Google Maps. Ultimately, we have to realize that every map is a point of view. It tells the story of its makers more than it shows the actual shape of the Earth. It serves as a reminder that the world we see on paper isn't the real world, it's just one version of the story.